Fifth one is fluorescence spectroscopy. It is a type of electromagnetic spectroscopy that analyzes fluorescence from a sample we are going to analyze. It involves using a beam of light, usually UV light, that excites the electrons in molecules of certain compounds and causes them to emit. And next one is flame photometry. A photoelectric flame photometer is a device used to inorganic chemical analysis to determine the concentration of certain metal ions, among them sodium, potassium, lithium, and calcium. This flame photometry is again divided into two types, that is atomic absorption spectroscopy and atomic emission spectroscopy. So first, coming to atomic absorption spectroscopy, it is a spectroscopical procedure from the quantitative determination of chemical elements using the absorption of optical radiation by free atoms in the gaseous state. It is based on absorption of light by free metallic ions. And second one is atomic emission spectroscopy. It is a method of chemical analysis that uses the intensity of light emitted from a flame, plasma, arc, or spark at a particular wavelength to determine the quantity of an analyte or element in a sample. The wavelength of the atomic spectral line in the emission spectrum gives the identity of the element, while the intensity of the emitted light is proportional to the number of atoms. And next one is X-ray spectroscopy. It is divided into three types: X-ray absorption spectroscopy, X-ray diffraction spectroscopy, and it is also called as X-ray crystallography. It is a technique that detects and measures photons or particles of light that have wavelength in X-ray region of the electromagnetic radiation. Electromagnetic radiation, in short form, we can call it as EMR. And next one is Raman spectroscopy. It is a spectroscopic technique typically used to determine the vibrational modes of molecules. Although rational and other low frequency modes of systems may also be observed, it is commonly used in chemistry to provide a structural fingerprint by which molecules can be identified. And next one is plasma emission spectroscopy. Plasma is generated by heating ordinary matter to high temperature, as is compressed of ions, atoms, and charged particles. As there is high energy electrons in the plasma, the ions and atoms present in the plasma gets excited to electronic state. Light is emitted when the ions are relaxed. These wavelengths are unique to each atom or ion present. And last one in spectroscopic types are photothermal spectroscopy. It is a group of high sensitivity spectroscopic technique used to measure optical absorption and thermal characteristics of the sample. The basis of photothermal spectroscopy is the change in thermal state of the sample resulting from the absorption of radiation. These are the different types of spectroscopic techniques we are going to use in pharmaceutical analysis.